Web HP Leakage Detector is the simplest software-as-a-service solution for active leakage control. In fact, the classical system based on the best practice EWA formulas have to use these formulas that you see, but in order to use these formulas, it is necessary to know the number of served inhabitants, the legitimate nighttime consumption per inhabitant, the daily pressure profile, and the N1 coefficient, a coefficient related to the pipe's material. The problem is that some of these data change day by day. For instance, the number of inhabitants change very quickly in touristic and business areas. The advantage of the HP leakage detector algorithm is, on the contrary, that it uses only the entering water flow in the district minus the exiting water flow from the district. It computes the water district balance, and on the basis of this balance, it makes a pattern analysis with which it computes the value of losses in the day. Let's see now the man-machine interface and the functionality of the service Web HP Leakage Detector. This view of the system is the top-level view. Practically, there is a public utility, and this user in this public utility has access to two different areas of districts. For each area in this view, it can see the total volume entered in this date inside each area, the total amount of losses for the area, a percentage, and the total economic value of losses in case they will remain at the level of this day for the entire year. Furthermore, he has some indicators that evidentiate the fact that in this area there are districts in alarm. Going down in the area details, I can see the losses data for each individual district, and I can see which are the districts with particular crises. For instance, in this case, the last two districts have a value of losses higher than usual, and the last one has also an increasing trend of losses. This gives us information about how to prioritize the intervention. All the information that you can see here, as it could be done in the previous screen, can be exported into CSV, which contains basically the same situation but permits to have a list which is prioritized in terms of level of criticism. From the area view, I can reach the analytical view of a single district. Again, here I can change the date of interest. I can see all the data related to this district, and I can see the historical evolution of losses in different periods selectable by the user. Once I have achieved the kind of view that I want, it is possible to export all these data in a CSV, which can be, of course, elaborated additionally with Excel, achieving more and more statistics and key performance indicators according to the need of the user. Let us see now the architecture of the Web HP Leakage Detector. We have a system, an external system, which is the user of the service. This system could be the one enterprise system of the public utility, could be remote SCADA, or the water management system of the utility, or it can even be a third-party software as a service from another provider, which uses the computation of the Web HP Leakage Detector in order to give its services. Practically, this green external system sends to the Web HP Leakage Detector the daily flows. Our service gives back to the user the computation of the daily losses. At this point, the green system can have its own HMI in order to deliver the results to the user, to the operator, or it can use also, possibly, the HMI of HP leakage detector that we have seen before. This is the typical architecture of a service. Let us see now a particular implementation of this architecture. It is the implementation where the Sofrel Web LS is interconnected with the Web HP Leakage Detector. In this case, practically, of course, WebLS is executing all its typical function, which is getting data from the field, stores them in an historical database, configure all the possible Sofrel data logger, which are handled by the WebLS, and then daily it collects the flow of data going through the districts, practically the district balances, and via FTP it transfers this data to the web leakage detector, which executes the computation of the losses and release the computation of the losses on its own HMI. This HMI is then reached by the user of WebLS through pointer which permit to the user to land onto the screens of Web HP Leakage Detector. Let's see now how this integration works. Practically, we have a WebLS which collects in particular, flow data from Sofrel data loggers. WebLS allows to configure remotely the data logger, maintain them, collect the data, store them in an historian database, and so on and so on. But WebLS allows also to introduce in our application some so-called business analysis. In this case, we have introduced a business analysis, which is in execution at this moment, which is oriented to collect data that has to be sent the Web HP LD leakage detector in order to execute the computation of losses. Practically, we have here the raw data. Let's exclude these two DMA. So we see what we have. We have here an exiting flow. Here we have an entering flow in the DMA. So this dark curve is the balance, the water balance of the DMA. And this is the datum that is necessary for making the losses computation. So this datum is the datum that is transferred via FTP to Web HP Leakage Detector. Now we see here that, for instance, this district is in this moment in alarm because it's red. From here, we can go to Web HP Leakage Detector in this manner. We have here a link. If I click the link, of course, I enter, being the first time I enter HP Leakage Detector, it is requested to me to make a login. I execute the login. Of course, this login operation was requested because it was the first time we went from WebLS to the Web HP Leakage Detector service. Once the session is established, for a certain amount of time, I am allowed to go through Web HP Leakage Detector coming from WebLS, changing possibly also the landing page or navigating with the navigation scheme of Web HP Leakage Detector freely. So I have the possibility to go in the two different environments freely. It must be pointed out that this integration between these two services, Sofrel WebLS and our Web HP Leakage Detector, combined together allows to supply both the functionality of a remote SCADA and functionality of a water management system, which could be possibly a complete solution for small public utilities which do not want to manage owned servers. Furthermore, Prometeo can also make studies on the measures acquisition system and on the waterwork management jointly with its hydraulic partner, even if, of course, if the customer is located in a remote location with respect of our headquarter, it is necessary to establish a cooperation with a local partner. Thanks for your attention. If you want more information, please feel free to contact us.